Hello and welcome back once again. My name is Arup Nanda. I run the data services at Priceline.com. So very quickly, what Priceline is, we are part of the Booking Holdings as a company. So some of you in Europe probably know about Booking.com, Kayak.com, Agoda.com, etc. Those are our companies, our parent company. William Shatner is one of the spokesperson as well, but along with Kelly Coco. I hope you remember that more than William Shatner. I took over this job about 5 months ago, and I'm going to talk about something that is fundamentally important to pretty much all of us combined, and that's what this one is about. When we talk about data, we always talk about something that's like this way, either Oracle or MySQL or Postgres or even Cassandra, etc., which is the NoSQL database. We always think about in terms of database, not exactly data. And that is a fundamental problem in our thinking, I believe. Because when I took over the data operations in Priceline, that's end-to-end, this was what I came up with, was that data means actually something in the database itself. If you expand that paradigm a little bit more, well, even Excel is also a database, kind of, if you open that. Because in our minds, we always think about the repository of data. But if you think about it, data is not necessarily in a static form. It also moves along from one end to another end and continues to move along. And if we don't think about data as a moving entity, as something simply to be stored somewhere else, we kind of fail in our professions. And this is something I changed my own way of thinking, and this is what I'm going to talk about very quickly today. So again, this is just a database as well, but that's not what data is all about. So here is another one, a Java program. Here's some things like the variables over there. Is that data? No, it's not, because it's nothing but a variable. A variable is not necessarily a data because it's not in transit, not being stored somewhere else. It's just using the program. So then what is the data? Yeah, I'll be talking about something called data engineering at Priceline later on this afternoon, but this is very quickly what this is about. We use streaming solutions. So for example, if you go to a customer comes to our website, we capture everything about the customer, where they come from, what they like or don't dislike, etc. We call that signals. We capture those signals into a pipe. So that pipe is Kafka, and we capture that. And then from here, we also store that into multiple databases. One specific database is our cache, because that's important for us to cache everything we have from the internet so that we can service you faster. Without the cache, we won't be able to get back to you quicker, and as a result, you'll probably go away somewhere else. So that cache, you believe it or not, is actually on MySQL databases. We actually have lots of MySQL databases, in fact, 192 shards of MySQL database spread across the entire thing. We have bots that go through something called global distribution system, which is nothing but like a stock market of hotels, airlines, and rental car information, where the providers put that in the thing. We go and grab that, and then we put into a pipe, and from the pipe, we spread across all the MySQL certs. That is data, but we never thought about that from the data side. Earlier, I was thinking data means that's what's in the MySQL database. Then from there, from the pipe, we also capture something and put into a Hadoop system. Why? Because we have to use that for historical purposes to do analysis, machine learning, etc., to find out how we can use or efficiently cache that information. So we put that into that as well. But that's not really useful for analysis, because most people are used to things of a relational nature. So we capture from there and move that into the Oracle database. We could have gotten that directly from the pipe this way, but we don't, because we don't think of that as data. When we think of data, we always think about them from the Hadoop. That's the data. And from there, if we move the data into something else, we grab that and move into something else. We could have avoided that completely by moving directly from the pipe, because what's in the pipe is actually data, but we don't think about that. We always think about what's in the database somewhere and move that around. And as a result of that, we simply increase the processing all the way. So this is the way I look at it from after joining Priceline, is that a pipe, multiple things go into the pipe and multiple things go out of the pipe. So why not filter right there what comes out of the pipe? So if we do that, we don't have to do things like ETL, etc. anymore. We can simply select what we need directly from that pipe, from the streaming system, and load into whatever you want. And if there are two different systems, for example, MySQL database is stored for our inventory data, we can selectively get the inventory data from the pipe and store it over there. And stuff like, which is not important for inventory, for example, our customer data, customer signals, etc., we can store that wherever we want. And then as a result of that, we don't have to move data from a database to a database. We can think about everything as a single data moving from end to end, and we can grab that and massage it in any way we want. So why not filter over right there? So that's what we do here. So we can filter it, move into specific databases, like this one goes into MySQL and other one goes into something else, and so on and so forth. So this is, so instead of moving the data from the one database into another one by using ETL, we can simply cut that out completely, the ETL, and then we can get that directly from the pipe itself. What is the problem? The problem is that we're almost always used to SQL, and that's the way I apply it. SQL is best used on a static data or database. So you can go and grab that. And that's the reason why we can't really filter it. We could have done that before, like using a Java program or something else, we can filter that, but it's not something, most of us are not used to that using Java program. So what we do today is something different called KSQL, Kafka SQL. So this is a new version of Kafka. It actually has a specific filter built into that. You can write SQL-like language, not exactly SQL, but it's pretty much like SQL, but it works on streaming data as opposed to static data. That's a big difference in terms of what happened in the past. So by using KSQL, we can actually look at the data that moves in Kafka as a data element and extract that however we want to use it. Here's an example of that one. This is how I use the KSQL. This is obviously not a complete treatise on KSQL. I don't intend to. Just going to give you an idea of how we use it. In Kafka, you can use something called a stream. So it's called create stream, a search path. When a customer comes to our search path in Priceline.com, they're searching for a hotel or airline or rental car. So we want to grab everything from there. I intentionally removed everything and just kept a few elements there. Something called sig time, that's a signal time. We have to capture that one, whatever signal came from. SIGWAIT, which is our unique identifier of a customer, because we don't require the customer to log in before they can do searching. So we have to grab that customer somehow to identify the unique customer. So we call that SIGWAIT. And then SIGKV, that's a key value pair of every signal we need to grab. Now this is interesting, SIGKV. We don't define all the attributes we want to capture beforehand. We don't have to, because we don't know exactly what attributes we'll capture. For example, today we want to capture your first name and last name. What if we want to capture your middle name as well? Or what if we capture your hyphenated last name as well? So because of that, we don't have to define the attributes beforehand. We simply call it key value pair. We grab it, and we also grab something called a VIP. If you have a VIP customer comes in, let's say you have already checked in, or you have spent a lot of money as before, and we know who you are, we want to grab a flag over there. That's what it is here, Kafka here. Then after that, we something called a create table statement. Now, this is not an Oracle or any other statement. This is Kafka SQL. So this create table statement is actually nothing but creates a table, but the difference is that data is not stored here. This is how the data becomes visible. Think of it as a view in Oracle when things are actually moving through it. And then from here, we create another table called VIP signals, for example. Here saying, how many people are coming through us who are VIPs? So by using the three different statements, I can direct the traffic into whatever I decide to use. And that's the fundamental concept of looking at data and not as databases. Because remember, Kafka is not a database, it's a persistent store. Things are moving inside that, and that's how we grab it. So this is what we did. So now this is how it is to look like before. What we did because by doing this filtering from the source itself, we reduced the amount of data by 60% from here. And the data that goes from the pipe over to the Oracle database over there, we reduced by 70%. And we also completely removed this ETL process. Overall, we reduced the data footprint down by 62%, which is pretty impressive if you think about it. We came down from a few petabytes over to a few hundred terabytes as a result of that. But more important, we also reduced the overall processing, which is I/O, CPU, etc., by 29%. Our journey continues. I'm there only for 5 months. This is It was a big change in only 5 months. As I guess we can see, doing this thing in the future, we can reduce that footprint and the processing time as well by significantly more as well. So the takeaway I want to go think about is that all of you should think about data, not necessarily databases, because we have been kind of programmed to think about our databases. Databases are not the only repository of data. Data moving is also data. And when I just mentioned Kafka, doesn't have to be Kafka. We also use RabbitMQ. Some people use IBM's MQ series, also data. We also do Splunk. So that also, to me, is like data as well. Take advantage of event processing where real time is not really important. Remember the picture I showed you from the signals we collect from the website, there is no reason to store that in real time into any kind of database. It doesn't have to be. But right into a pipe, event processing, and then put that as an offline processing into the databases. That will speed up the process as well. Filter from the pipe itself. And now we have the technology to do that. We probably didn't have that before. And think in terms of ETL. Do not think of that. Think in terms of data engineering, because you're moving from point A to point B, and we're transforming and while we're doing it. It's not storing, then transforming, and then storing again. That's not how we should think about it. Data engineering. So that's it. That's all. I thank you very much for listening. I hope it was enjoyable.